Hi, in this video we're going to look at how we go about drawing a straight line graph using the gradient intercept method. So, gradient intercept, two words that we've heard about before. Gradient referring to the slope of the line, intercept referring to where the line crosses the axis, one of the axes. Now, in particular, the intercept that we're talking about here is going to be the y-intercept. So the gradient intercept method is a method that looks at getting the gradient of the graph and getting the y-intercept or the y-cut of the graph and using those two values to help us draw the graph. So let's get some equations up. Now in the first video when we drew straight line graphs using a table of values, one of the things we saw when we did a review of the graphs afterwards was that the slope of the line was generally governed, or was always governed, by this number over here. This number here was causing the graph to be steeper or less steep, to be positive or negative. And this value here, the value that's in front of the x, the coefficient of x, is in fact the gradient of the graph. We also noticed that when we were using the dual intercept method, when we wanted to get the y-cut, in other words, when we made x equal to 0, that first term, the term that's got the x in it, is going to disappear, and this number at the end over here, this one, gave us our y-cut, because that is what y would equal when x was equal to 0. So what we have here is the y-cut, while in the red, that's what our gradient is. And if you remember, we use the letter m to give us our gradient. So for this first graph, the gradient is 2. But hang on, you said to me gradient was rise over run. 2 is only a single number, it's not a fraction. Well, I can always write 2 as being 2 over 1. And that gives me a rise of 2 and a run of 1. Here, my gradient is going to be 3 over 4. A rise of 3 and a run of 4. Here, gradient is going to be minus 2/3. And here the gradient is going to be 5/2. And the y-cut we can always pick up as being that number that comes at the end, and so that tells us straight away what our y-cut is going to be. So let's get a set of axes up and go about drawing these graphs. So if we take our first graph, the graph y is equal to 2x minus 1, we know that it's going to cut the y-axis at minus 2. At minus 1. We know that it's going to cut over there at minus 1. That's one point that I know for definite on the graph. Now, the gradient, the rise over run, is 2 over 1. So it means from that point, I can go up 2, rise 2, and then run 1. There's my next point. From this point, I know that I'm going to rise 2 and run 1. And so I can collect a whole lot of points. That's going up. If I was going down, I could go down 2 and across 1. Down 2 and across 1. We can see that we're getting our line of points there, and they are going to be the line that's going to give us y is equal to 2x plus 1. Right, so let me go and fill that in. Let's go and get a shape over here, and it's going to be a straight line running through those points. There we go. And down the bottom here, I'm going to extend it out to the edge of the frame. Now that is something I noticed in some of your graphs when I was going through them, that you were only joining up the points that you had selected, and that's wrong. You must draw your line all the way out to the extreme of the graph. And the other thing that you must do with it is you must go and write what is the equation. So you identify that line. That line has the equation 2x plus 1. So there's the first example. The second example, well, that is y is equal to 3 over 4x plus 2. So I know that my y cut is at plus 2. It's going to be over here. So I've got 1 point on the line. In order to be able to draw the line, I only need another 2 points. So from this point, I'm going to go up 3 because my rise is a rise of 3. So it's going to go 1, 2, 3 up to 5. And then I'm going to go across 4. 1, 2, 3, 4. Oh dear, I can't go up. I don't have enough space to continue up beyond that. So I'm going to go back to my starting point over here. And now, instead of rising by 3 and running by 4, I'm going to drop by 3. 1, 2, 3. And then I'm going to run by 4, but I must make sure to go the other way. 1, 2, 3, 4. And there are 3 points, and that's sufficient for me to be able to draw a nice, accurate line. So I can now fill that line in. Here it goes. Those points. I've got this bottom one quite right. Oopsie, that's not right. There we go. So that's given us our line going through those points. This is the line y is equal to 3/4 x plus 2. My third graph, what color shall I do that? Let's do it in black. My third graph has a y cut of -3. So in other words, I start down here at -3. The gradient is -2 over 3. So there is a rise of 2. There's a run of 3. But the line has to go that direction because the gradient is negative. So from the point -3, I'm going to rise by 2. 1, 2. And I'm going to run 3. So I'm going to go 3 across to the left. 1, 2, 3. There's my first point. Can I go on from there? 1, 2. Yes, I can. And 1, 2, 3. There, I've got my next point. I could have dropped down 2, 1, 2, and gone across 3. 1, 2, 3. And there I've got 5 points all in a line, 4 points all in a line. All I need to do now is join them up. And I can do that with a line that runs like this. Yeah, it's not quite as easy as it looks when trying to draw a line on a graphing package like this. No, that hasn't got it. Missed it off. There we go. And there we've got our third line. And this is the line y is equal to -2/3 x minus 3. And I'm not going to worry about the fourth one at this stage. The graph is just becoming a little bit too cluttered now. So hopefully that gives you an idea of how we can go about drawing this graph using the gradient intercept method. Beg your pardon. You need to have the gradient, you need to have the intercept. You start off with the intercept, mark that point down, and then pick up 2 further points using the gradient. Now, I don't know if you noticed, but all of these equations were in this format over here. Y is equal to 3/4 x plus 2. They were all in the form where y was the subject of the equation. Now, sometimes you're not going to get the equations looking like that. Sometimes they're going to be in a slightly different format. Now, let's just think about what might have happened, what could happen with this equation. I could go and write this, couldn't I? I could say y minus 2 is going to equal 3/4 x. We're just going to take away 2 from both sides. And I'm never a great one for fractions, so why don't I go and multiply everything through by 4, and I'm going to get, not 4x, I'm going to get 4y minus 8 equals 3x. And if I rearrange that, I can have this statement. I can say minus 3x plus 4y minus 8 equals 0. And that is another way in which a straight line graph could be written. And remember, when we did the dual intercept methods, they tended to be written like this. So if you have the equation given to you in this format, where y is the subject of the equation, then the dual intercept method is most probably going to be the quickest way to use. If you have it in this format over here, where all the x's and y's and numbers are all on one side of the equation, and you don't have any one subject, then sometimes the dual intercept method is going to be the correct one to use. And that's something you're going to learn with experience, drawing lots of different graphs in lots of different situations. You choose the method or the approach that's going to be most suitable for you. Right, there's a task for you to tackle. So that's all for this video. Hope it all makes sense to you. Goodbye.